Okay. Hopefully, too many of you aren't disappointed that you're not learning about JRuby and instead talking about SQLite. But if you are disappointed, I'm hoping that by the end of this talk, you will be excited. Because I want to talk to you today about how and why you might want to run SQLite in production. So, a little bit about me. My name is Steven. I am at Fractal Mind on Twitter. And no, I will not be calling it X. I am an American, and I moved to Berlin, Germany about 5 years ago. And in 2.5 weeks or so, I get to marry my fiance, who is Russian, who moved to Berlin about 10 years ago. And she's actually here today. This is her first time watching me give a conference talk, so I don't feel any pressure. At my day job, I'm the head of engineering at a company called Test.io. We are a crowd-driven quality assurance testing provider. But in my free time, I am an open source developer, actively contributing to and maintaining a number of different gems, a lot of them in the Rails and SQLite ecosystem. And I write on my GitHub Pages blog, and you can find a lot of content, and I'm going to be talking about a lot of things that I have been writing about these last few months. So this is how I start all of my new Rails applications. And what I want to talk to you today about is why you might want to start your new Rails applications this way as well. And specifically, I want to talk about why you might want to use SQLite as your database engine. Now, when I suggest this on the internet or in conversation, the first question I always get is why? Why use SQLite in production? And I'm curious, has anyone here ran or currently are running an application in production that is using SQLite? Okay, I see a few hands. Has anyone spent more than a few minutes with the Rails default before they went in and changed it to Postgres and used SQLite in your Rails application on your local machine, but you made sure to change it to Postgres or MySQL before you pushed it to production? Yeah, a couple of hands. So one thing I always do when I get this question is I just turn it back around. Right? Why not use SQLite in production? Why change the default? And I'm actually curious, does anyone have some reasons? Like, have you hit pain points? Are there things you've heard? Yeah. Yeah, so it's a common issue that people talk about. Right? It's like, hey, I need my data to be persistent. And if I just have a file on one server, what if something happens to that server? Do I lose all my data? My company stops existing? Okay, that's definitely one thing. We're going to talk about that today. Any others? What are some reasons you haven't used SQLite? Well, there are a lot of myths that have some grounding in reality, and I want to talk about today. One of the big ones is can't really scale. Like, sure, you can do it on your machine, but if you put an actual application on production, you have actual users. Are you going to be able to handle more than 10 users? What are we going to do because SQLite doesn't allow concurrent writes? A lot of these issues. And fundamentally, what I want to do today is show you that as of now, a lot of these myths are not true. They might have been true to some degree in the past, but they aren't. And it's time to start reassessing our priorities. As for why I like to use SQLite in production, DHH in his keynote at Rails World re-emphasized the point that Rails at its core is the one-person framework. It bridges complexity to empower the smallest possible team, right? Just you on your laptop by yourself, to build full, rich, valuable web applications. And I believe that SQLite is the perfect companion to that vision. Firstly, because it is simple. The database is a literal file on disk. The engine is a single executable. And this means that you can fully embed the entirety of the database into your majestic monolith. And that simplicity gives you some unique control, because when everything is embedded into your application, it becomes possible to configure everything directly in your application, right? You can set up all of the fine-grained details of your database and how it needs to work in your repository code, checked in to get you don't have to make sure to SSH into your Postgres server before you go to production and get the settings just right. And it's also fast, right? When your data lives on the same machine as your application, you just remove network latency. And so you immediately go from measuring queries in milliseconds to microseconds. And microseconds are fast. That's really fast. And it opens up a lot of unique possibilities when your data retrieval is happening in microseconds. It's literally in the SQLite docs that there's really no point in thinking that much about N+1 queries when working with SQLite. Make as many queries as you need. And this works particularly well when you're using an ORM like Active Record. It can become troublesome to have to tame your queries and your interaction with the database to ensure that you're making as few and as efficient as possible the queries to the database, because just the handshake and the network latency make it costly to do 200 queries inside of one web request. And that just isn't a problem with SQLite. So that's fundamentally why I like to use SQLite in production. But what I want to really focus on today is how. Like, what does it look like to actually build, deploy, run a full-fledged web application on SQLite? So let's start where every project starts, with a minimum viable product. And we're going to start the way I always start. We're going to use modern Rails tools and get something going. Now, in this next step, I originally was planning on doing a bunch of typing and showing you that I'm a real coding ninja. But I realized that was a complete waste of time. None of the details of the application have anything to do with SQLite. They're not particularly useful to this talk. So I want to instead just show you what I've made, and we'll use this code base as the foundation for the rest of the talk. So, how's the font size? Is it good? Should I go up more? Up more. Okay. Better? So, here is an incredibly simple Hacker News clone. We've got users. They've just got a screen. Let's not worry about authentication. They have sessions, so we can sign them in. We're just going to do all this with the database. They can create posts. Posts just have a title and description. We have a counter cache here. And those posts can have comments. A user creates a comment, just as a body. Not going to do anything with voting and ranking right now. Super simplistic. We can see the simplicity here in the browser. So we have the ability to sign in and sign up. Once you are authenticated, you can view the details of your profile. You can sign out. You can create a new post, edit one of your old posts, create a new comment, edit one of your old comments. Publicly, anyone can go and look at posts. And we're also going to bake in some benchmarking. We're going to use this later to get a sense of the performance characteristics of this application. Really quickly, just to show you what we're doing there. This is a custom controller I worked up to make it easy to get some dynamic real-world usage in the application without having to send a whole bunch of parameters. So we've got a read-heavy benchmark where we're mostly doing hitting the post show, hitting post index, hitting comment show. This is like the percentage distribution for how often these things will happen. But we also create posts, create comments, destroy posts, destroy comments. Write heavy, just a different distribution of percentages, a balanced workload. Before all of them, we will update the user's last seen. So we're going to run 3 queries here to find the user, then another query to update them, create a post, create a comment, destroy. Right? This is pretty standard for what this application is doing, and we can hit this endpoint and benchmark the performance of our application. Let's just start running this and see what it's like. So super simple. We have a landing page, shows 100 of the most recent posts. You can go look at the details of the post, look at the details of a user, what posts they created, what comments they created, jump around. If you want to sign in, we're not really doing fancy authentication, just give one of the screen names you'll masquerade as that user. You can edit one of your posts, but not one of somebody else's. You can create a comment. That'll get sent there. Okay, simple stuff. This is going to be the foundation of what we're going to work with. So we've drawn the owl. We have an application. It's working, it's running on our local machine, but obviously this is about running SQLite in production. How do we get it in production? There are a number of different hosting providers that make sense, but a critical detail is that Heroku is not one of them. Any hosting provider that only provides you with an ephemeral file system cannot work as a hosting provider for a SQLite on Rails application. You have to put the file on disk, so you need a disk and it needs to stick around. There are a number that do. Fly.io, Render, Hatchbox are 3 of the more popular ones for the Rails ecosystem. I personally use and love Hatchbox, have used it for years, though it is a little bit lesser known than Fly or Render. It's essentially just ops as a service. You give it a DigitalOcean account or a Hetzner account or a Linode account and a repository and say, deploy this app, build a server, this account, and it is basically like a web UI for running shell script that it manages. And again, originally I was going to do a bunch of typing and we were going to deploy an application live, but I realized I don't want to just sit and wait for 10 minutes as it actually provisions the server. So I did that earlier, but I took screenshots of literally every screen so we can see genuinely, like no magic, how quick and easy it is to get this application up and running. So what does it look like? What does it take to do this in Hatchbox? Well, we need to create a cluster. Hatchbox has this concept of clusters because, of course, this is the standard way that Rails applications run, right? What is the way to have an app in production? Well, obviously, you need to have 3 instances of your web app, 3 different servers with a load balancer. Then you're going to need 2 different servers with res, with different eviction policies, naturally. Then you're going to want 1 server with your primary Postgres database, a different server with your replica Postgres database. This is all pretty straightforward. What we have, that's only like 7 servers. I'm sure the network topology is fine. I'm sure all the security there is all good. Or we could just do the one. But what we're going to see is we're only going to create the 1 server. But for Hatchbox, we do have to start with this idea of a cluster, though we're not really going to cluster a bunch of servers. We just get to work with the simplicity we want. So we say we're going to use DigitalOcean. We need to connect our DigitalOcean account, jump over to an OAuth flow, give it access to our team. Once we've done that, we just need to choose what region do we want to run this server in. DigitalOcean has a number of options. Let's choose Frankfurt. It's pretty centrally located. Once you've chosen your region, you can start creating servers for this cluster. So Hatchbox is going to remind us that our server has to have at least 2 core responsibilities. It has to be able to run a web application and it needs to be able to run as Hatchbox ensures that the migrations are automatically run. So let's configure a server to do both of those. And then we can decide what size of server we want. DigitalOcean has a lot of options in the Frankfurt location. The largest one is 32 gigabytes of RAM with 8 CPUs and is $192 a month. But for this MVP, let's just choose the smallest, simplest, cheapest option, $4 a month, 512 megabytes of RAM, 1 CPU. Once you've told Hatchbox to go, it'll start provisioning your server. This will take some time. In reality, it takes about 10 minutes when I ran it. And then it starts to provision your server, get everything set up. You can view the logs here in the web UI, see everything that it's doing. It's not hiding anything from you. And when all that is done, your server is ready. We just need to deploy the application to it. So let's jump over and create our application. Go to the Apps tab, click on New App. We have to tell it what cluster do we want to deploy this to. Let's choose our new cluster. And let's create our app. It's just going to ask us for our Git information. If this is your first time running, you can connect their GitHub app to your account. Or if you're using a different Git host, or if you've already connected their Git account, their Git app, you can just choose that. And you just provide the repo name and the branch. That's it. Everything's ready. Let's deploy the app. It'll start deploying. Again, were I doing this live, we'd have to wait about 3 minutes for the first deploy. But it finishes pretty quickly. And now we have an app on the internet. This is production. It is up and running. And I would actually love for anyone with a phone or a computer to go ahead and go. Like, let's go and look at the demo. Because I understand that the first thought that we're all likely to have is, sure, you have an application, and it is, I guess, technically running in production. But is it usable? Right? We have this app, it's running on a server in Frankfurt. We're here on conference Wi-Fi in Taipei. Does this thing even work? So I want you to like explore the app, click around, and I'm going to do that myself. Let's see what it feels like. So here we are. This is not a load app. This is the production application. Let's reload the index. Already got some users. Cool. Thanks, Thomas. We can view a post. That was pretty snappy. Let's go look at this user's details. 11 posts, 97 comments. Let's go look at this particular post. Comments. We can sign in as this user. Not too bad. Edit one of their posts. Update that. Right. Usable. This is not an application that is in any way unusable. I think it's completely fair to say that this is good to go. Now, is it amazingly fast? Is this cutting edge stuff? No. But did I spend 4 total hours to get to this point? Yes. So the cost benefit analysis there was really working in my favor. But let's make this a little bit more concrete. We have our benchmarking scripts. I'm using this simple command line utility called Hey. It's a load testing utility. And I ran our 3 different scenarios with increasing concurrency load, 10 seconds each time, and ran each of them twice, took the average. There, down at the bottom, that's the average requests per second for each scenario, read, write, bounce. Take the average of that, 21 requests per second. Now, to be fair, I ran these benchmarks in Berlin, next to Frankfurt. I realized maybe that's a little bit fishy. Let's do it from Taipei. I ran this in the hotel Wi-Fi yesterday. Just did the balanced one for being able to do it faster. We're at 14 requests per second. Now, I'm not here to claim that this is some amazing number, but it is absolutely good enough. I asked on Twitter earlier this week, just for some anecdotal information, people running production Rails applications. What are your requests per second? Here's a table, the 6 responses. Now, is this setup able to handle the 3 busiest applications here? No. Can it handle the 3 less busy ones? Yes. And it took me 4 hours, genuinely, from start to finish. I ran Rails new. I was looking at the production side 4 hours later. And this is an app that could be making money. It's good enough. So this is the first major point I want to hit. Running a SQLite on Rails applications, even just 1 year ago, wasn't viable. You weren't going to get this experience. There are reasons why these presumptions that we have in mind are there. I'm going to talk more about them shortly. But today, a vanilla Rails application running on the smallest, cheapest DigitalOcean droplet with a completely vanilla Hatchbox deployment process is fully usable from Taipei to Frankfurt. Just one server. We're not distributing our compute to the edge, taking on any of this complexity. This is an excellent choice for MVPs, for research and development projects at your work. You can get from nothing to a production application in hours and not months. And you can actually have in your mind a full understanding of what your application is doing. All of the details of your operational setup are embedded in your repository. And I really want to hammer home that this is the reality today for Rails applications. So let's talk a little bit about what has changed recently, and then I want to talk a little bit about how we can take our app to the next level. So why are things different today than they were even just 3 months ago? two major changes in the Rails ecosystem. So the first is that as of Rails version 7.1.0, there are new defaults for your SQLite database. These are the defaults. If you want to learn more about what each of them does and why these are the 6, well, a blog post about it, feel free to read it. The key central detail here is that we are running our database with the write-ahead log. This is how Postgres, this is how MySQL are doing things. The default original way that SQLite was developed is using a rollback journal, and it's just much slower. Write-ahead logging, smarter, faster, but it's not the default. SQLite never changes its defaults. It's all about backwards compatibility, so you have to opt in to that. The other big change is that we have changed the default compilation for the SQLite executable. So when you run bundle install SQLite 3 months ago, you would get an executable that did not have any of these flags. This is the same thing here. We're telling at the executable level, we're saying, you are going to be running in wall mode. Forget about the rollback journal. We don't need any of that. We're not going to use it. These two things together completely change the experience of working with SQLite. There was a research paper from the University of Texas in the post, you can read more about it. They were doing some detailed benchmarking and changing this one change, right? I want to use the write-ahead log, and I want to flush to disk synchronously at like level 1, is a 12x improvement on performance. And it also completely changes the nature of dealing with concurrent load. And this was a major problem because obviously web applications, we have concurrent load. SQLite, if you just pull it off of their website and try to run it, it is not designed naturally, originally, for the web application context, right? And it has taken us to really sit down and think about what are the levers to pull to make it work in that context. So that's the key reasons why the experience today is different and better. But I don't want to stop here, and we shouldn't have to stop here, because if you have a research and development project at work, and this is where all of my experience with SQLite production comes from, running, creating these small research ideas to see, maybe we can create this new service, maybe we can sell into this market, maybe we'll get some traction here. We're not sure, so we don't want to invest a ton of time. And some of them connect, some of them click, and we start getting some traffic. And I know that it doesn't make any sense to put an application on production when you know that if you start to get any traction, you're going to have to re-architect it. I'm not going to stand up here and recommend to you to use SQLite in production if you can't evolve your application over time with it. So let's talk a little bit about how you can start leveling up your application. Right? Let's move beyond vanilla, add in some flavor. And there's a lot of really cool things that have been happening in the ecosystem recently. I want to run through them. So the first most important thing that you should do is add the enhanced adapter gem. The enhanced adapter gem is going, as of like today, bring in 5 key features. The first 2 are adding features that are present in Active Record, present in SQLite, but as of the current Rails version, you can't use them. The actual Active Record adapter doesn't connect them. Both of these are pull requests that are now in Rails main, but they just haven't been released yet. You want them in your Rails 7.1 app? Go get the gem. Now you can do generated columns with SQLite. The next 2 are enhancements to the database YAML file, right? We really want to embrace this idea that we can embed all of the operational details of our application into our repository. So if we want to tune the runtime settings of SQLite through the pragmas, that is available through the database YAML file. If we want to load extensions, that is also there. And then the major point here is that we get improved concurrency support. This is something, again, it's going to be upstreamed into Rails, but Rails has a much slower, like pull request review and merging process, and then eventually getting released. And we don't want to have to wait 6 months. Like one of these pull requests took about 4 months to get into main, and then we'll see, when the next version is released. I want to highlight two of them though. First one, what does it look like? You want to load an extension. Showing you an example here, highlight two key points. One, PG vector is not the only kid on the block. You want to do vector similarity search? SQLite's got your back. There's an extension for that. There's a gem for that extension. You want it? Bundle add, SQLite VSS. You want to load that extension into your SQLite database? Pull in the enhanced adapter gem, just add to your database YAML file. I would like to use that extension, please. 2 steps, you're done. And now, you have to use the extension and set it up. I've got so much time trying to hit these key things, but SQLite on Rails, ready for the AI revolution. The next big one, though, is improved concurrency support. Now, the app that we deployed to production, if you recall, on the smallest, cheapest DigitalOcean droplet, 1 CPU, Puma's running in single mode. By default, it needs multiple CPUs before it spins up multiple workers. Let's go back to our application and just do some local benchmarking to see what happens with our SQLite on Rails application when we run Puma in clustered mode. Okay, so go to our profile. We're just going to force Puma to run in clustered mode. So spinning up a bunch of workers. I've got a 10-core MacBook Pro, so that's why I'm setting it to 10. And let's run a balanced benchmark just for 1 second with 128 concurrent requests. Let's see what happens. So the first thing to note, it's been more than 1 second. That's a sign that something has gone wrong. Waiting it out. This is the long tail. All right, let's see what happened. We had 19 successful read requests. We got like post show or post index. 7 201s. We successfully created things. 4 201s. We deleted things. 54 500s. Yikes. And we see here our slowest request took 17 seconds. Okay. Now, this is why we have these myths. You can't run SQLite in production, right? I won't get totally into the weeds here about SQLite locking, and it locks the database level, not the row level, and doesn't allow for any kind of concurrent writes. I have written a lot about this. You can go and read more about it. The key detail here is that this is another example where the default out-of-the-box experience for SQLite is not tuned for web application. But SQLite is an incredibly powerful and flexible tool, and it is possible to tune it to web application usage. So let's just remember this: average 6.3 requests per second, slowest request 17 seconds. A vast majority of our requests, more than half, were errors. Let's add the enhanced adapter. Record, enhanced SQLite 3 adapter. Now, the gem automatically hooks into Rails and sets itself up. So you just have to install it. We do get to have the experience of the conference Wi-Fi. That's okay. But once it is installed, we just restart our server. Here we are. We got 10 workers again. And let's just run that exact same command, see what the experience is like now. So, 2 key points. Point number 1, 0 500s, no errors. Point number 2, slowest request, 2 seconds. Requests per second, 58. So we 10x'd our RPS and we removed all of the errors. So is it possible for SQLite and Rails applications to handle concurrent load? Absolutely. Do you have to tune SQLite to tell it, hey, we're in a web application context, we need to do this work? Yes. Will that default be in Rails in a few months? Also yes. Can you have it today? Yes. Okay, I think we're getting the trends here, right? Things are different today than they were 3 months ago. Let's talk about a few other details. So, what's happening here? What is the gem doing? The major thing that it is doing is it is implementing a custom busy timeout handler. By default, we delegate that to SQLite. And so it's running in C. But with Ruby's global interpreter lock, well, it's retrying, no other Ruby code runs. And that's terrible for concurrent load. So we say, we will handle that in RubyLand, and in RubyLand, we use sleep, we pass the global interpreter lock around between our multiple workers. It allows our workers to naturally coordinate with each other to line up and execute linearly the work that they need to do. Okay, a few more details. We also have the ability to fine-tune the compilation of the SQLite executable itself. So there's 2 defaults. That's great. But if you go to the SQLite documentation, it's actually going to recommend these 3, 6, 9, 10, these 10 compilation flags. Now, this is a little bit more extreme than Mike D'Alessio wants to put in the default SQLite Ruby implementation. Understandably so, this is very much tuned for web applications. But if we really want to extract the maximum amount of performance out of our Rails application, we should compile SQLite the way that SQLite tells us to compile it. Beyond just tuning our application, enhancing the natural performance of it, we can really start to take advantage of SQLite and extend its power as well. This is my absolute favorite. How many times have you been working with the team? You're on your branch, you're doing your feature, pull request comes in, hey guys, it's urgent, I need you to review it. You switch over to the branch, look at some stuff, looks good, switch back. Conflict, schema conflicts because they had their migrations, you had your migrations, Postgres is all messed up. Wouldn't it be nice to have isolated databases for each branch? But they were fully set up, right? Run all the migrations, get everything there. If you have seeds, run them all. They're good to go. It's 2 lines. It's the easiest thing. You just tell the database file, use my branch name as the database name, tell Rails in development mode after you've initialized it, make sure the databases are ready. So as soon as you go into Rails console, as soon as you kick off the server, it's going to create those database files, run your migrations, run your seeds, get everything there. Switch between branches. It all just works. I use this all the time. This is awesome. Good luck, Postgres. Next, we talked about the need to have backups, right? We have this persistent data. It is essential that we actually persist it. And if it just lives on the file as one server, something happens to that server, start to feel risky. I know this is true because I have deleted my production SQLite file. These things happen. Backups are important. Now, luckily, People have been working with SQLite for 30 years. There are a lot of great tools that have come out. My absolute favorite is a cool tool called Lightstream. It allows you to stream all of the writes happening to your SQLite file into any sort of S3 compatible bucket storage system. Now, we in the Ruby community have created a gem, bundles together that executable, so you can bring it into your repository, and then you want to integrate that into your app. Bin Rails generate Lightstream install. All right. We're moving quickly here at the end, but that's because the enhancements get a little bit bigger to talk about. All the links, though, the slide will be up. There's a lot that you can look into. Last thing to talk about, LightStack. Who here has heard of the LightStack project? Cool. Welcome all of the rest of you. This is one of the coolest projects in the Rails world today. LightStack allows you to SQLite all the things. What are all the things? Database server, cache server, job processor, pub sub server, full text search. Every single Rails component that requires some degree of persistent data, you can back that with a SQLite file. You can put every piece of Rails functionality onto 512 megabyte RAM, $4 a month DigitalOcean server. LightStack, similarly, incredibly easy to install, automatically integrates into your Rails app. It'll update, the installer updates all the different configuration. So I hope that at the end of this, you're a little bit warmer to the idea that, especially in the Rails community, we are at the cutting edge of taking advantage of the unique possibilities and power of SQLite to run our web applications. And it really does make sense for certain apps in certain contexts to embrace SQLite in production. Thank you.
Thank you. Thank you for your informative sharing. Now we gonna have very quick Q&A session. Does anyone have any questions? Please raise your hand. No? So now we'll thank you, our speaker, Stephen Margheim, and give him a great ovation. Now we are